One of the mysterious functions in Unix is the fork function. The fork function creates another copy of the running process. So there will be two running processes. The first one would be the parent, and the second spawned copy of that parent would be the child. The child does not run from the very beginning of the main function, but rather continues where the at that point when the fork was invoked. The parent and the child each has a different copy of the variables. They do not share variables. They proceed in parallel on their own parallel paths of execution, um, and their only relationship is that when the child dies, um, it notifies the parent by sending a signal to the parent, and the parent can also retrieve the exit status of the child. So this is one way of achieving multi-threading, but more specifically, the correct term is multi-processing. Multi-threading is only deal with a single program with multiple threads running within that single program. And an important term to introduce here would be context switching, since we will be dealing with multiple instructions running in parallel. So these instructions would be alternating, or will context switch with each other. So I'm doing a printf hello main to illustrate that the child process does not run from the very beginning, but rather continues on a separate path after the call to fork. The fork will exit twice. It exits in the instance of the parent and returning that the PID of the child, and in the child instance the fork also exits returning a 0 to the child. So the way to determine the instance of the child is to compare if the child is 0, in which case we will know that this block here will be in the belongs to the child, and we will add an artificial for loop here to let the child do something, and put a delay sleep of 5 seconds within each loop. Take note that the variable c is not shared between the parent and the child. The child has a separate copy of the variable c, and the parent has its own copy of the variable c. On the other hand, this is now the parent process, and again in the same manner it does a for loop of 10 and have a delay of 2 seconds. The parent will exit first because the delay is 2 seconds, which gives time for the parent to wait ahead for the child to exit. The parent will block in the waitPID function call. It will block here, which means it will wait for the child to exit, returning and retrieving the child's exit status in the status variable, and we can display that value here. The parent will return we'll say it will return to 5, and the child we will say it will return 69. We will add a message here saying that the child has exited, and another message here saying that the parent has exited. Okay, we will add a tab here to 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 display to display clearly the child and the parent. Okay, we see that the parent exited first, and it waited for the child to exit. The child continues on with a for loop of 0 to 9. After that, the parent unblocks from the wait period function and retrieve the child's exit status of 69, and we can also verify that the parent has an exit status of 5. That's all, folks, and I hope this small tutorial is helping you in some way in how the Unix fork function behaves. Thanks, guys, and good luck.